So very good afternoon, guys. Today we are on the day 6, also on my day 42 of solving the Geek for Geeks streak challenge. And today's problem is find the shortest safe route in a matrix. So what is the shortest safe route in a matrix? They have given a question like this. They're given a matrix, two-dimensional matrix with rows and columns C, where some cells are landmines marked as 0 and the others are safe to traverse. Our task is to find the shortest safe route from any cell in the leftmost column to any cell in the rightmost column of this matrix. We cannot move diagonally, so we must avoid both the landmines and their adjacent cells. Okay, so we cannot move diagonally like this, and we must avoid both the landmines and their adjacent cells. Okay, up, down, left, and right, as they are also unsafe. So, given a matrix 1 0 triple 1 1 1 1 1 1, the output is 6. We can see that the length of the shortest route is 6. So the shortest route is 6. They have highlighted 1 plus 2 plus 3 plus 4 plus 5. 1, 2, 3, 4, 5, 6. Yeah. Let's cover the second. There is no possible path from the first column to the left. Okay. So this is how we are going to calculate the shortest safe route in a matrix. So let's go with the problem statement. Yeah. So first we have seen that there's a class solution has been defined and a template of static int find the shortest path has also been defined. So we have to code over here int equals to 0 semicolon I and length for j equals to 0 semicolon j less than mat. Mat is the matrix. Okay, so if you are confused what is mat is basically the matrix, and the inner loop is basically for the column and the outer loop is for the rows. So in the inner loop, for the outer loop we are using the rows, and basically the row is going from till the 0th position to the end length of the matrix, and the inner loop is the column which is going from the uh, 0th position to the matrix first element length, like that. Semicolon j plus plus. You can also go and check my previous videos if you haven't checked. They are also very good. Like showcase the concept needed for all the combinations to solve a Greek for geek problems, and basically they are like Fibonacci. Then there is a binary search tree and all those problems like that. So I plus one, if you are confused what is I plus one and all, I will explain in detail. And also I plus one is basically denoting the adjacent cells or the adjacent elements of the matrix. Okay, mat dot length, mat of I, mat of j plus 1, equals minus 1. Then we have to, uh, yeah, over here we are going to initialize, a dynamic array, multi-dimensional dynamic array, where we are going to add length, add length, add. It's so confusing. Sometimes you just think math as math, so let's not confuse length. We have to traverse through each and every element of the particular um, array. So we have to give a for loop condition, dp. Now we have to fill the array with the previous elements until min equals to integer dot max. And we have to traverse a for loop again, when the I equals to 0, I less than mat length semicolon 9 plus plus mean equals to math dot min. Over here min comma recursive. You have to again make a recursive function. Mm, so I guess this comes under a hard problem of the geek for geek problem challenge, because not every day the problem statements are like this interesting or a bit harder side of the problem. Because whenever you are dealing with the dynamic programming concept and multi-dimensional array concept, you will see that the problems kind of get a bit hard. So in order to facilitate hard problems, what we can do is, like, we can practice more of course, but we should get our fundamentals clear. There are many popular YouTube channels available for the fundamentals and description of that. Currently, I'm in the pre-final year of my college, so I don't have the time to explain the fundamentals sometimes. Maybe in future, we can try for explaining the fundamentals as well. J and DP, you can see that made a function, recursive function, which will recursively call the elements. And in this function, I have to pass some if conditions, map dot length less than 0 or j less than 0, mat of I j or mat of j and so on. We have to return integer dot max underscore value. If j greater than equals to mat 0, we have to return if you find j equals to 1. Yeah, there's too many if conditions. I know people will be getting confused, but I will try my best once the problem is completed to explain the each and every line of the code. Another thing I feel like, if you can say like ChatGPT is taking the world, and like all these problems can be easily solved with ChatGPT. Well, in today's companies and today's commands, like companies and colleges, they don't really check, give you questions or syntaxes. So syntaxes can be made correctly using a AI software, but in order to develop the core application of the core knowledge behind a particular problem, you should have basic your fundamentals clear. So companies basically check that how clear is your fundamentals. How strong are your fundamentals? Dynamic programming, integer dot max value. Yeah. So the main element is equals to math dot main of main comma recurse math comma I plus one comma j comma dp. We have to calculate mil multiple times. So let's, since whenever you're finding the shortest route, the multiple times min is calculated, and for that we have to work on the multiple times how the min should be calculated. So first is the I plus one, you can see. The next is the I minus one, and the last one is I minus one j, and the last one is I and j plus one. So these are the common techniques which we are going to follow, because this type of problems usually have the same formulas, and finding the shortest safe route is also done using this formula in multiple questions. The more questions you solve, you will see that this formula has been used multiple times. So you will not feel a bit different while solving this. dp of ij. Whenever you're using a two-dimensional matrix, we write like this: dynamic programming dp is the multi-dimensional matrix with I and j as a row and column as their matrix size. Yeah. So if min equals to integer dot max value, we have to return dp of ij equals to min plus 1. Return, so we have to return the dp of ij. Let's compile. So what is the compilation error? We expected a semicolon in line number 83. Expected a semicolon in the line number 83. Yes. On line number 89, we again missed a semicolon. Funny and irritating at the same time. When you miss a semicolon, it is very, very irritating. We have also missed a third bracket in line number 95. So in line number 95, uh, to check, int dp equals to new int mat dot length. Okay. Oh, I made it. I wrote it twice. Mat 0 dot length. Yeah. Let's try. You see, whenever you are working on an online compiler, you get to know a lot of things, and you get to understand a lot of things, like how the compiler works and all those things. So let's check the errors in line 97. Arrays.fill, arrays.fill of I comma minus 1, and line number of, they're also saying another error is in line number 103. So line number 103 is return of min equals to integer dot max value fisherman minus 1. And this looks good. Let's try. Line number 103, Int cannot be converted to boolean. Is it so? Oh, I missed it. Double equals to. Yeah. So let's see and check for the last time maybe. Expected output 6. Oh my god. Output is -1. Let's ask the AI bot for the output. Let's try this. Uh, what's the code? It should work. Yeah. So let's dive into the problems which we are facing over here, and let's explain each and every line of the code step by step. So for that, the first thing which we can see is like we are creating a class solution, and inside that we have declared a static method find shortest path, which takes a 2D integer array mat as the input, and it will eventually return an integer. Next line of code includes some for nested loops. This nested loop iterates over each element of the 2D array matrix. So you can see if the current element is 0, it marks the adjacent element as -1. This likely represents marking obstacles of a grid for path folding purposes. Okay, path finding purposes. And after that, we have declared, so we have initialized a 2D array DP with dimensions similar to the input array mat. And now we have to fill the array with -1 values using arrays.fill. And you can see we have used arrays.fill I comma -1. So in the place of the ith elements, we are putting -1 in order to fill the adjacent elements. Next, we have done like this, that int min equals to integer dot max and for loop again. So we are basically initializing a variable min with the maximum possible integer value, which is iterating over each row of the matrix and finding the minimum of the result of the recursive function. For each row, we have to update the min variable accordingly. Next, we can see is like we have to return -1 if the min remains as its initial value. Otherwise, we have to return min. Then we have declared a static int recursive function. This is the recursive function basically. So let's discuss the recursive function. So static method recursive function, which is also taking a 2D integer array and two integers I and j and a two integer array dp as input and returns an integer. The first if condition basically checks the current cell I comma j is like the position of the element is out of bounds. Out of bounds. Why? Because the element you have to stack it shouldn't be less than 0 or less than 0, and row cannot be less than 0, or the column cannot be less than 0. All those things, or the element is -1, or if it is already visited. Whenever something is already visited, we are putting it as 0. If any of these conditions are met, then we will return the integer dot max value. Next condition is if j greater than equals to mat of 0 length -1, return dp of ij equals 1. So it basically checks the current element is at the last column. So if it returns 1 and assigns 1 to the dp of I and j. So basically if the current elements at the last column, then we will assign the integer 1 to the dynamic, why I'm using the word dynamic, to the particular coordinate. Next we are checking the if the but if the value is already calculated, that is it is not equals to -1, then it returns the particular value. Lastly, we do is initializing a variable main with the maximum possible integer value and sets to the maximum possible integer value. Now we have seen that we are calculating main 4 times. Recursively, we are calculating the minimum path length from the adjacent cells I plus 1, j, I minus 1, j, I, j plus 1, j, I minus 1. So you can see in the first recursive function what we are basically doing, matrix is there, then the second adjacent element, the adjacent row, and then we are passing the dynamic like new matrix. Similarly, we are doing with I minus 1. So we are trying all different kind of combinations of the positions of the rows and column and finding the minimum path length from each adjacent cell. Lastly, we have to update the minimum path length. We are using dpij equals to min. Now, if the min is not equals to the integer dot max